I'm going to argue that reproducibility, while important, is actually not the big picture. Reproducibility is the means to a higher end. It is a fundamental building block to the advancement of scientific discovery. It enables generalization across research findings and propels the evolution of knowledge as driven by confirmation or refutation of prior or future findings. Okay, well, the principles of reproducibility have actually been historically applicable in experimental practice and academic dissemination for a long time. And the spectrum of reproducibility and its extension to the concept and nuance of generalizability have likewise been historically applicable to research investigated for a long period of time. So if we just take a look at what the spectrum of reproducibility is, it actually breaks down into two larger components here. One of them is actually about re-execution itself. So that means using original data, original analysis, and original data and original analysis, which should produce the same result. Or re-execution, in which you use, well, sorry, I've actually, re-execution meaning you actually go and pull that again, and you do the exact same things, you should get the same result you did the first time. So you can then also look at generalizability, in which you may use the same data and nominally similar analyses. It should yield a similar result. Or nominally similar data, exact same analysis and nominally similar data should yield a similar result. Or nominally similar data and nominally similar analysis should yield a similar result. So we've got two big chunks there, but that's a spectrum of reproducibility that we're working with in science overall. So if we accept the notion that reproducible experiment or publication is not a new idea, and that reproducibility is a fundamental cornerstone of scientific work, then how do we modify a traditional publication to include computational information that is essential for technical re-execution of today's neuroimaging research studies, and to communicate findings such that others can generalize to and from our work? So how do we get there in the hyper-computational realm of neuroimaging? So this is where the ReproPub comes in. We want neuroimaging research to make a positive impact on people's lives, and we need the claims of the neuroimaging literature to be more generalizable. But what we need and currently do not have is a way to report the computational specifications of our study components. This is currently a problem, since publications, in order to maintain readability, do not typically provide a complete specification of the analysis methods or access to the exact data. So this is really something that has come in with computational work, big data in general. So this brings us to the definition of the ReproPub. So the construct is a re-executable publication of the future includes words, as with traditional journal articles from other types of work and in the past, but it also includes supplemental information. So this is getting at the computational specifications of data, workflow specification, execution environment, and by execution environment, I actually mean things like what computer operating system you're working on, what's the versions of software you're working on, all of those things that actually, which we all know, you know, even if you change your operating system, your email doesn't work. So, you know, just think about the larger ramifications of that in these experiments. So these are where defining all the particulars become really important. And then actually having the complete results as well. Now, if we consider some of the basic elements of a neuroimaging experiment as an example, well, okay, the framework of this is really very much comparable to the classical experiment line that I actually just showed. So there are various research components. There's subject information and data acquisition. There's raw data, analysis and workflows, derived data and publications. So there are a lot of different steps. And what's really critical here in this context is that in any neuroimaging experiment, every single one of these components is highly computationally intensive. So it means there's a lot of information and there's a lot of complexity and there's a lot of detail. So that is going to lead us to research object, but I actually want to talk about Prodnerson because all of these different computational pieces of information in each of these categories are quite important. Okay, so the research objects actually take any of these research elements that along this timeline, actually, plus the associated provenance or the history, the origins for that element. And in addition, introduce a digital link which connects the specified research element with its provenance. So, for example, a data research object might include a data set, which is the research element, plus some associated provenance, such as the scanner hard and software versions that were used to collect the data, as one small example. A workflow research object could include a specific workflow, the research element, some associated provenance, such as a containerized workflow. I realize I haven't gotten into that, but an encapsulated environment, including all the particulars that are important, including execution environment plus the version control script. An example of a statistical research object could include a specific statistical analysis, which is the research element, plus its associated provenance in the form of a version control script that was used to run a specific analysis. So in each of these cases, there is, in addition to information, there is a digital link connecting the specified research element with its provenance. So all of these things can be attached, and that means they can be retrieved, they can be found all together, and therefore used all together. Okay, so if we now come back to the ReproPub as a re-executable item, we're now looking at, as we said before, words as usual, plus the supplemental information for each of these research elements. Okay, so given this construct, ReproNum investigators and collaborators took on the challenge of creating a fully re-executable experimental workflow to see if it would stand the test of publication level reproducibility. It sounds good, but what does it really mean, or what does it require? And how can this problem be defined simply to serve as a proof of concept? So this simple proof of concept experiment is run simple data analysis in this case, which is a specified, working with a specified data set and a defined workflow and an execution environment. Look at the results that are generated by the execution of this workflow on that specified data set. So run the analysis, collect the provenance for each research element, and link to create research objects. So do that experiment, and then after doing that, come back and verify the re-executability or not under each of the generalization conditions on the reproducibility spectrum. So the simple one proof of concept test is to actually work with a specified data set. And that's actually publicly available. It's open access. There is a data set for this, a specified workflow, a specified environment, and then look at the results. So even though I'm using this as an example of what the construct is for a reproducible or re-executable publication, I'm actually also going to just give a little bit of what the experiment inside it is, because I find it helpful to think that we are talking about brains. So it's a very simple workflow, but the workflow actually involves identifying and differentiating between different types of brain tissue in a specified sample. So gray matter, cortical and subcortical, white matter, and whole brain. And this, by the way, is just a reference image. This is actually just for educational purposes. It's actually not from the study itself. So take the tissue types, identify them, and then the task is, okay, segment the subcortical gray matter of the brain in these 24 subjects with basically to calculate volume. So we really want to look at the volumetric result for all the designated subcortical brain regions. So this is just 3 different views, so a lateral view, coronal view, and an axial view going through the brain. So it's just to give a sense of the 3-dimensionality of the task. And remember, we're looking for volumes. So the output of that analysis would be a volumetric results. The only reason I'm putting this here is to show that basically what we're getting is numbers per brain region within the task. So for each of the designated subcortical brain regions, as we're shown here, we're actually just getting a number which is cubic millimeters per structure. So the test is run the experiment, and then the next component of that is, okay, if you now provide all of this information, provide the access to the data, provide the workflow and the environment, and somebody else does exactly what you've done with the same data, this should be completely re-executable and they should get the same result that you did. So that's the brain part of the experiment. So you come back here and in fact, designated data, designated workflow, designated execution environment, designated results, and it actually did work. So in this construct, a simple analysis executed on a publicly accessible data set, which by the way is right here, and you the audience, anyone could actually go to any of these specific, the data or the workflow, the results, the environment. You should be able to do this. One should be able to do it themselves actually, because all of the information has been made available here. So in this case, we ended up with a publishable repropub with a hybrid of text and research objects. And it did prove to be re-executable across 5 different users directly from the supplemental materials in the repropub, which allowed readers to combine materials, methods, and provenance. And while I actually did forget to mention it, this actually is in fact a published article. This is an F1000 paper. So this is the citation. So it actually really did work. So from that paper, actually, just pull out a little bit, which is that authors are concluding that this provides a roadmap to enhance the reproducibility of neuroimaging publications, and that we expect that these types of publication considerations will advance to a point where it can be relatively simple and routine to provide such supplementary materials for neuroimaging publications going into the future. Great, okay, so that's our proof of concept. Now the next thing is, well, if we're really gonna start working with re-executable publications and we really want to be able to take the best advantage of that as a research, that in the future means being able to share data and for other people to also be able to work with it. So, and for test and retest of your work and other people's work. So the second step of this process is to do a re-executable publication, or try to, testing a hypothesis. And in this case, we're actually, given that we know repropub is feasible, let's do the experiment in this repropub way and identify an hypothesis that has been reported in the literature by someone else. And in this case, that hypothesis is IQ is positively correlated with brain volume in typically developing children. And test that hypothesis using not their data, but using similar data. In this case, it's all relevant data from open source data in the BIBE1 and ADHD data sets with similar workflow, with a similar environment, and look at the results. So on the reproducible experiment, we have similar data and similar analysis yielding a similar result, and a generalizability outcome would be a similar result, should give generalized reproducibility. So actually here, we actually have a specified hypothesis. We have given workflows. We have open source data sets and the statistical analysis, and all of these things are computationally defined. And for this particular hypothesis, in fact, the query did result in a positive correlation between IQ and brain volume. So the conclusions for this are that in this simple 2 test of this construct, we actually were able to test the generalization of a published finding using similar but different data and a similar but different analysis. And the retest experiment yielded a similar result. As Ruben folks also found a positive correlation between IQ and brain volume in typically developing children in a fairly large sample of 479 subjects. So they found the similar result to that published by authors earlier in time. So to sum that up, there's now, we now have tested the generalizability of a prior finding in the literature published by others by redoing the experiment in a similar way using the repropub method. The resulting ReProPub study will now be identically re-executable given the supplemental computational information collected and linked to our experimental steps, meaning all the steps that were used to do this in the ReProPub way are publicly available to others. So somebody else can now go to that, pull those same exact pieces of information and work with them. So it makes the study now living and expandable by us or by others with the use of different or additional data that can be exactly re-executed, analyzed or reanalyzed as the case may be, for generalizability of results in an ongoing fashion. Okay, so if we recap the problem, we started off with a focus on reproducibility and the goal for more reproducible research. Why? Well, because reproducibility is a fundamental building block to the advancement of scientific discovery, enabling generalization across research findings, and propelling evolution of knowledge as driven by confirmation or refutation of prior or future findings. And we concluded that this emphasis is not a new idea. In fact, reproducibility and generalizability are and have long been intertwined in the process of scientific experimentation and publication. But neuroimagers and big data scientists in general actually are facing the dilemma of how to modify a traditional scientific publication to now include computational information that is essential for technical re-execution of neuroimaging research studies, or any other big data study for that matter, and to communicate findings such that others can better generalize to and from our work.